So how do we make beer? Well, beer is made from four main raw materials: grain, hops, yeast, and water. The main grain that's used worldwide is barley and has been for thousands of years. A lot of beers also wheat is the main grain, but let's focus on barley first of all. And when we're talking about barley, we're talking about the grain, the seed, if you would. That is what is going to go back into the ground to make a new plant. But we are going to not call it seed, we're going to call it a kernel or a corn. And that is the raw material that is used for making beer. There are many types of barley. There are feed grade barleys, but we're interested in malting grade barleys, those that are going to be particularly useful to the brewer. They're going to have a high amount of starch in them, and it's the starch that is the fundamental starting point for the process. Most of the barley in the United States is grown in states like Idaho, Montana, the Dakotas. A lot of grain comes down from Canada as well. So each of those little grains is basically a baby plant. There's an embryo which thinks it's going to become another barley plant, and it's got a food reserve associated with it. And that food reserve is primarily starch, but it's all wrapped up and needs to be exposed. You take that barley, the barley grain, it's very hard, it's very tough, it's very difficult to chew, and it's very difficult to digest. And if you took that barley grain and tried to make beer out of it, you'd be seriously disappointed. So what you have to do is to malt the barley. And this happens in a malt house or a maltings. And there are three basic stages to this. The first stage is called steeping. And the water that is added to the grain is going to go in, get the embryo wet, and the embryo is going to start the processes by which the grain is broken down and softened. So that steeping takes about 2 days, and then you're going to germinate for about 4 days. You're going to sprout the grain partially. And what is happening in this process is you're going to make something called enzymes. Now, enzymes are catalysts. They are things that do jobs for the grain. And amongst the enzymes you're going to produce are the ones that are going to break down the starch later on in the brew house. The starch doesn't get broken down in the malt house. It's going to be broken down in the brew house. So these enzymes are developed. They soften the grain over a period of about 4 days, and then you've got to stop the process. And the way you stop the process is by drying. We call it kilning, and it takes about a day. And what you're doing is bringing warm air through the grain to drive off the water, and that stops the germination from happening. Now, you've got to do it carefully because these enzymes don't like too much heat. So you do it carefully to produce a relatively dry malt, a pale malt that is going to be useful for the brewer. Now, you can produce different types of malts. If you dry gently, you're going to produce a pale malt, even more gently, a Pilsner malt, and the word Pilsner we'll come back to in a later lecture. These are the workhorse malts that are going to be used by the brewer. So they're a rich source of starch, and the enzymes need to break down that starch. And they've got a gentle color, lemony, pale yellow color, but they've also got a gentle sort of flavor, a biscuity sort of flavor. If you've ever had malted milk balls, they taste, the inside the chocolate, tastes of malt. If you ever have cornflakes, they don't taste of corn, they taste of malt. They put some malt on there to give that nice flavor. Bedtime drinks like Horlicks or Ovaltine made out of malt. But if you put some more heat in there, you produce specialty malts. So if you heat a little bit more intensely, you develop more color and more flavor. Things like crystal malts and caramel malts. These, because they're heated to a higher level, they don't contain enzymes. So you can't use 100% crystal malt to make a beer. You always have the pale malt as the main malt, but you add these specialty malts to give more color and more flavor. So if you're making a darker pale ale, then you might use increasing proportions, a few percent of a caramel malt. Then, if you heat still more intensely, you go right the way through to the chocolate malt. This happens on a roasting drum. And now you've got a lot more color, darker, blacker, and you've also got more intense flavors like chocolate and mocha. And even more intensely, you go through to black malt, where you've got burnt coffee-like flavors. In the production of a famous Irish stout, they use some roasted barley. The barley isn't even malted, it's not germinated. The grain, the basic grain, is just heated intensely, just like you'd be roasting coffee on a drum. And that gives you the very, very harsh, astringent, dark character. Now you can make malts out of other things as well. You can make malts out of wheat or rye. If it's a cereal, if it's alive, you can convert it into a malt. There are many different malt types. This is a rich palette that the brewer can use to produce beers with different flavors and different colors. Now, some brewers use adjuncts. There are some people think adjuncts is a dirty word. It isn't. This is an alternative source of carbohydrate. One of the most widely used cereal adjuncts in North America is rice. It's well known that Budweiser and Bud Light are 30% rice. And that's not because it's cheaper. It is to give a very light color and a light flavor. In the malt, the outer layer of the grain in the barley is called a husk. And that husk is very useful to the brewer because it's going to make a filter bed in the brew house. We will talk about the lauter tun, and the husk makes that filter bed. But the husk also has on it materials that give you a dry, grainy, astringent character. And if you want to tone that down, then using something like rice is very useful for doing that. Actually, to use a cereal like rice is more complicated because in the brew house you have to cook it separately. And that is an extra energetic stage which costs money. Some brewers use corn and the same considerations apply. Some brewers use some extra sugars. And one of the most famous brewers that does this are the Trappist monks. They put in candy sugar into the boiling stage. Candy sugar is derived from sugar beet. They put it into the kettle, the boiling stage that we'll come on to later on, because they want to boost the level of sugars that is available to the yeast. The more sugars, the more alcohol is produced. So if you want to make a really nice alcoholic Trappist beer, candy sugar is very, very useful indeed. Let's turn to hops now. Humulus lupulus. There are male hop plants and there are female hop plants. And in the world of brewing, it's all about the female. The hop cones. So the flowering body on the female hop plant is known as a cone. And that cone contains all the materials that the brewer is interested in. They are the resins, and these provide the bitterness, and the oils, and they provide the aroma. The biggest growth location for hops in the world is the United States. And within the United States, by far and away, the biggest growth location is Yakima in Washington State. Somewhat further behind in terms of quantity would be Oregon and the Willamette Valley and Grants Pass, but also Idaho. And these hops are also, our other main market for growing hops is Germany. Germany in the Hallertau region, very famous for its hops. Also, the Western Czech Republic in Bohemia. There are hops grown all over the world, some fine hops from England, some fine hops from Tasmania, from New Zealand, and so on. The key components in the hops are known as the lupulin glands. These are yellow, sticky glands which are inside the hop cone. So these yellow glands, as I say, called lupulin, contain the resins and they contain the oils. The closest relative of hop, I would say in passing, is marijuana. Now, the hops grow on trellises. They're annual plants. The rootstock survives year to year. And what happens each year is that the hops are trained up this wirework up to 16 feet high. So they're quite complicated to handle and quite demanding in terms of all of this threading of the hops, and the harvesting of the hops is a very complex business. The hops are quite wet when they're harvested. Some brewers love to use fresh hops to put into their beer. So there's a beer style called fresh hop. And that is the ultimate in terms certainly of aroma, using these hops when they're fresh. But if there's a lot of water there, they will tend to deteriorate. And of course, brewing is a year-round operation. The wine guys talk about the crush. A brewer's crush is 365 days of the year. That is a crush. So they have to be dried for any long-term storage. And this is done on a hop kiln. And then they are stored as airtight and as cold as possible. One way of storing them is in these big sacks. In England, they're called hop pockets, not to be confused with hot pockets. But in the United States, they're likely as often to be in bales. But these hops are packed in very, very tight to exclude oxygen. If oxygen gets in there, it turns the hops cheesy, and we really don't want that. If you want to detect whether the hop is cheesy, but also if you want to confirm that you've got the hop variety you want, and different hops will give you different aromas, the way it's done still to this day is to put the hops between your hands and rub them like that and smell. And you can smell if there's any deterioration, but you can also confirm that you're getting the aroma you would expect for that hop. Now, there are some brewers, including Sierra Nevada, who insist that the only really good way to hop a beer is with the whole cone hops. But other brewers like to process them into pellets or even into liquid extracts made with carbon dioxide, liquid carbon dioxide, because they are easier to handle and they also are more efficiently used. But if you really want the ultimate, the closer you can get to the native hop, the better. Now, we can divide hops into bittering hops and aroma hops. The bittering hops are those that have very high levels of resin, so they give a very high bitterness potential. But the oils don't smell too good. The aroma hops usually have much less bitterness potential, but they have great aromas. Some people call them noble hops. Now, there are many hop varieties. And you can choose your hop variety depending on the sorts of aroma you would like to get. We can divide the hops into those that primarily give a floral character, or a fruity character, or a citrus character, or an earthy character, or a herby character, spicy, or pine. And different hops will give you different emphasis in these areas. And so again, just like there's a palette of malts that you can use and adjuncts, there's also a rich palette of hop varieties that you can choose from. Now, the main component of the vast majority of beers, in fact, pretty much any beer really, is water. So the number one constituent of beer is water. And so you better look after that water, because that water will influence the flavor of the product. It will also influence the process. But when we consider the water, it's not only the water that is in the finished beer that we need to worry about. There's a water used elsewhere in the brewery for different purposes. For example, cleaning. And also, brewers heat up the water to produce steam, which is used to heat up vessels. And of course, water is also used to cool things down. So a really good brewery will use about 3 barrels of water for every barrel of beer. And it's very hard to get much under 3 barrels of water per barrel of beer. But there are 1 or 2 brewers that have succeeded in doing that. Now, we can classify waters in terms of their hardness. And what I'm describing is how easy it is to work up a lather with soap If you've got soft water, it's very easy to make a lather when you're using soap. But with hard water, it's much harder. Now, not a lot of soap involved in brewing beer. That's just a test. What's the difference? Well, soft water contains very low levels of salts, but hard water contains very high levels of calcium. And we can divide it into permanent hardness, and that's primarily calcium sulfate, or temporary hardness, that's primarily calcium bicarbonate. And it depends on the terroir. I know the wine guys talk about terroir, but if anybody can talk about terroir, it's the brewer. So if your water's coming from a region that is rich in, say, gypsum, then it's going to be very high levels of permanent hardness. If you come from a region of limestone or chalk, then it's going to be a very high level of temporary hardness. The softest water in the world is from Pilsen in the Czech Republic, the home of the great Pilsner beer. Very, very soft water, very, very low levels of calcium. The hardest water is in Burton-on-Trent, England. Extremely hard water, very, very high levels of calcium and of sulfate and bicarbonate. And this influences the process and how things work, the efficiency with which you can extract hops and much more besides. And of course, influences the flavor of the beer itself. Now, people say to me, oh, if I want to make a great Burton ale, do I have to have these phenomenal levels of calcium? Or if I want to make a Pilsner, do I have to have really, really soft water? The answer is no. What you have to do is to make sure that the level of the salts is the same every time from batch to batch. And then you'll achieve consistency. And consistency is what it's all about. So yeast. People were still arguing about what yeast is in the mid to end 19th century. Chemists thought it was ridiculous to think that there was a microorganism, a microscopic beast that was making alcohol. They thought it was all about chemistry. In fact, in the Middle Ages in England, they used to call it God is good. All they knew was something surfaced in the fermentation and they could skim it off and put it in the next one, and that kick-started the next brew. So they said, God is good. Well, actually, it's brewing yeast. Brewing yeast is a single-celled fungus. You need a powerful microscope to look at a yeast cell. And it grows by budding. So imagine that I'm a single yeast cell and suddenly a little me starts popping out of the side, and then will grow and grow and grow until it's identical to me and then splits off. Now we've got two of us, and then each of us will divide again, so we've got four. This is what yeast does. It reproduces by budding and multiplying. So by the time you finish your fermentation, you've got a lot more yeast at the end than you did at the start. There are two types of brewing yeast. The first is called ale yeast, and it's given the Latin name Saccharomyces cerevisiae. And the second is lager yeast, Saccharomyces pastorianus. You can go all over the world and you can isolate Saccharomyces cerevisiae. So this ale yeast, there's lots and lots of different ale yeasts, and they've been isolated all over the world. But you can't go out into nature and isolate lager yeast. Saccharomyces pastorianus is a more complicated yeast that arose probably sometime in the last 200, 250 years by two different yeasts merging together. One of them was Saccharomyces cerevisiae, and the other one was a wine yeast called Saccharomyces eubayanus. And they merged together. So there are far fewer lager yeasts. Now, people ask what is the difference between an ale and a lager, and we'll come back to that in the next class, but the fundamental difference is, are they made with Saccharomyces cerevisiae or Saccharomyces pastorianus? So what happens during a fermentation? And how do we monitor a fermentation? Well, we monitor it by measuring the decrease in something we call specific gravity. If you've got water, pure water, and you've got a milliliter of pure water and you weigh it, you will get 1 gram. If, however, you have sugars dissolved in the water, the weight will be higher. And so you may have 1.04 grams. That's the specific gravity. So when you start the fermentation, the liquid extract from the malt, which we call wort, it has got a lot of sugars in it. And it's got a high specific gravity. When the sugars are removed, the specific gravity goes down. And another contributing factor is the alcohol. As you produce more alcohol, alcohol has got a very low specific gravity. So the way that brewers monitor fermentations is to follow this drop in specific gravity. You might have done it at home with something like a hydrometer. The other thing that goes down is the pH, the acidity. That drops as well. Of course, you produce alcohol and you produce carbon dioxide. And you produce more yeast cells. You probably have about 3 times more yeast at the end of a fermentation than at the start. Usually, as long as the alcohol content isn't too high, you can reuse that yeast. So some of it is used to put in, we call it pitching, the next fermentation. God is good. But there's always going to be a surplus. So what are you going to do with it? Now, if you are an English person, or British person generally, the chances are you either love or hate a product called Marmite. And that's how the company markets it. You either love it or hate it. My wife loves it. I'm not so keen. If you're in Australia, it's Vegemite for you. They're very similar. So these are extracts of yeast. Alternatively, you can sell it to distillers, because distillers making things like whiskey, they're not as fussy about the yeast as a brewer is, or you can sell it to pig farmers. Pigs love yeast, at least in part because it's still got alcohol associated with it. The yeast also makes certain flavor compounds, and we'll talk a lot more about that in a later class. So that's the raw materials, but what is the brewing process? Let's turn now to the guy responsible for brewing the Sierra Nevada beer at the Mills River Brewery in North Carolina, Scott Jennings. So I'm talking now with Scott Jennings from the Mills River Brewery of Sierra Nevada. Scott, what's your job title? What do you do?
I'm the brewmaster here at the Mills River Brewery, and I'm essentially running the production of beer at this facility.
So basically, I guess that means everything from raw materials coming in to what point?
To finished beer ready to package.
Okay, so...
And that's where we hand it off to the packaging department.
So let's talk through the brewing process. I mean, you've got, let's start with malt. Malt's coming into the brewery. Talk us through the various stages it goes through.
Well, once we receive it, and we can receive our malt in various ways, by rail, by truck, and it goes into silos. We transport the malt, of which, of course, there are many types. Depending on the recipe that we're making, you'll have different blend of malts.
Right.
And we bring those together as a batch to the mill, which is the first step of the process.
Right. And so you mill, you're grinding up into small particles, which are easy to extract. And how do you extract them?
Well, in the mill, we are milling or grinding as fine as we can while preserving the husk around the barley to the greatest degree possible. Right. And that is mixed with water at very specific temperatures and very specific amounts. Right. And then we're bringing that to the mash tun. Right. And the mash tun, the sole function is to facilitate converting the starches that are in the malts into various sugars.
And now you're going to transfer it to the lauter tun.
That's right. Yep, the lauter tun is call it a separator, right, if you will. So we're taking our mash, which has a component which is in solution at this point in time. That would be the sugars that we have created in the mash tun. Right. Now we're trying to recover them. But also with that, you have a fair amount of solid material that's insoluble. And that could be said to be mostly husk material, cellulose. It won't dissolve. And so the lauter ton, we're separating liquid from solid, recovering, you could even say, the liquid, which we could maybe call extract at this point. And then we are recovering as much of the extract as we can while filtering our solution, which we'll call wort, all at the same time.
And so you're washing through with hot water, sparging.
Yep, sparging,
And that liquid now is going to...
Well, we're essentially going to the kettle, but there is a sort of a step along the way. At this particular brewery, you don't find that in every brewery, but we do have a wort receiver. That's just a holding tank to allow us to run the lauter tun, collect wort, and have a place to put it when the kettle is busy with the previous batch. So it allows us greater throughput.
All right. So in the kettle, you're going to boil.
Yeah.
Boil vigorously. Yeah?
Right. Right.
And how's that heated?
Steam. Yeah, with steam. We have in this kettle a system called an internal calandria. Think of it as a shell and tube heat exchanger that is inside the kettle and submerged in liquid. And so steam is flowing on the, say, outside of the tubes, while the inside of the tubes is open to the contents of the kettle and would be full of wort.
Right, so it's going like this.
That's right. You create a thermosiphon.
Right. And hops added at this stage.
Hops are added for the first time, generally speaking, in the kettle.
And those are going to be whole corn hops.
They are, yeah. Lots of them.
So how do you get rid of those residual hops?
Well, we have another unique vessel in our brew house, and it's called a hop strainer. Right. Think of it again as a sieve of sorts. So all the whole cone hops that we're adding in the kettle have to be removed again, because it is a lot of matter and quite large particles that you can't really pump through heat exchangers and so on. So you remove it in the hop strainer.
So you come out of the hop strainer into a whirlpool next.
The whirlpool, yeah, that's right. So the whirlpool is there to you could think of it as a settling process to allow precipitated protein that forms during the boiling of the wort to settle into the whirlpool. Interestingly, in the center, at the bottom, and so then you can, in a way, pump the wort off of the precipitated protein, leaving it behind.
So now it's got to be cooled.
Yes. So we cool it using there are many ways to do it, but we use a plate heat exchanger.
Right.
Not unlike a radiator in a car where you're cooling down your coolant, but in this case we're cooling down our wort.
Right.
And we're not exchanging that heat with the air.
Right.
We're exchanging it against cold water.
Right.
So cold water on one side of the plates, hot wort on the other, the energy is exchanged, out comes hot water, which goes back into our water plant for mashing in the next batch.
Okay.
And the cold wort then goes on to aeration, followed by yeast pitching, followed by fermentation.
Okay. So how do you monitor that fermentation? Is that a manual thing, or is it automated in some way? Or?
Well, it's a mixture of both. Of course, we can monitor the temperature and the pressure in an automated platform, and it's monitored continuously with recorded data for every minute of every day, 24 hours a day. And within our automation system, we can alarm operators if there's something wrong with the set points.
But what about things like the specific gravity and the pH?
Yep, that's right. So with that going on in the background, in an automated manner, our cellarmen go through and collect samples twice a day, and we are measuring for gravity, specific gravity. We are measuring for cell count in a lot of cases.
So how many yeast cells you've got?
During primary fermentation, pH. There are a number of other quality checks that are done, everything from the amount of alcohol, the amount of diacetyl present.
Diacetyl being very important. That's the popcorn butterscotch flavor, which develops but then subsides.
That's right. It reduces at a pretty predictable rate, and so we do have release criteria for that and many other parameters as well, where we need to see the numbers in a certain range for a specific beer recipe at a specific time of that beer's life. And that's how we're proceeding along with fermentation management. You're producing much more yeast during fermentation than you're putting in there in the first place.
Right.
Then the excess yeast, we discharge it at a very constant but slow rate to our wastewater treatment plant.
Oh, I see.
And then there, it's essentially converted into biogas, which we then bring back to the brewery and feed it to our steam boilers.
Okay. All right. So, but you're not making Marmite from it, right?
No, not here.
How do you separate the yeast from the beer? I mean, do you have a centrifuge to do that, or
You mean during fermentation?
after fermentation?
Oh, okay. Yeah. Well, that's the point of the design of the conical bottom tank. So when you start to cool the beer after fermentation has completed, and in some cases before that time, the yeast is starting to settle. It's working its way down, to the bottom of the tank, and now you have a cone shape.
Right. So you can pull it off first.
And you open only the very bottom part of the cone, and you're really able to get a pretty clear separation of yeast and wort, which we can visually see, but we can also measure that with turbidity sensors inline.
So now you're going to go into a cold tank?
And a lot of times it stays in the tank that it started out in, and that's the origin of the term unitank.
Okay.
It's the same type of conical tank, but you're making primary fermentation, cooling, and maturation all in the same tank.
Right.
We do that on occasion, but also we have a system here that we call our green beer transfer lines, and these are just pipes, and we can move the beer from the fermentation tank to a maturation tank, and we have the option. We have a lot of options on this line. We can centrifuge it totally or partially. We can crash cool it using an inline drop cooler heat exchanger, and put it in. And depending on the beer type, we do have different procedures for different types of beer.
So now you're basically in the final stage, the bright beer tank.
That is true. And that's an interesting term nowadays because, believe it or not, most of our beer that we're producing here is not filtered at all. Only pale ale, draft pale ale, some lagers, things that really need to be very, truly bright, hence bright beer tank. But many of our beers are centrifuged only or centrifuged partially, and might not be actually bright and clear, but they are finished beer.
Right, so it's a finished beer tank.
Finished beer
or the
tank.
final beer tank.
You can call it that, sure.
Tell me about the control center. It's a bit like Houston, isn't it?
Well, I wouldn't say so. No, it's very very basic. Say manufacturing automation. We do have a control room. That's centrally located between the brewing. We call that hot side, yeast handling, fermentation, and filtration. And our brewers are using that as a hub. And everyone's there together, for the most part.
But you can see on the screens, you can see all the tanks.
Yep.
You can read off what the temperature is.
Yep.
And how much is in there and those sorts of things.
Yeah, that's right. So we are highly automated.
Right.
But we do have a pretty good mix of manual tasks that have to occur as well.
Right.
For example, sample collection. You have to do this multiple times for every brew that runs through the brew house.
Right.
And believe it or not, the brewer is rarely sitting at the desk. It's a very challenging job because you're monitoring 5 or 6 batches that are in different stages all at the same time. So you have to keep track of batch A through F, let's say, and then you're sampling all of those as you go. So a lot of up and down the stairs, down to the basement to collect samples, looking in the vessels, opening them. All the hops have to be added manually.
Right.
All of our dry hopping is done in a manual fashion as well. And filtration, of course, has its manual operations too.
Now you mentioned dry hopping. And you got torpedoes here.
We do, yeah.
Briefly tell us without revealing too many state secrets.
Well,
Just tell me about a torpedo.
It's interesting. That's one of the things I think, one of the many things we have to be really proud of here at this company. We invented the torpedo, more than 10 years ago now, as a way to dry hop a tank, a fermentation tank, with whole cone hops. Before that time, we would do a technique that we still do to this day with Celebration Ale and Bigfoot, which is you have these mesh bags and you stuff them full of hops,
So
and then you
porous
have to,
bags that you put in.
Yep.
If you talk to the, you've got a QA department here, they're making lots of measurements, but as a brewer, you're actually doing lots of tasting of things all the way through. You're tasting the water, you're tasting the malt, you're making sure everything, you taste the wort to make all of those things?
Yeah, of course, yeah, and it does start with the water. Yeah. We taste every source of water that we use in the process every day. And we taste our malt that comes in, and along with comparing or checking the certificates of analysis that the specifications are correct. And we are, feeling and observing the texture of the mash to make sure that the milling is
Just like
correct.
a chef.
Oh yeah, sure, yeah, and not only that, but you're listening all the time to the sound of the pumps, and you can hear the valves opening and closing, and you can hear a lot of things that can tell you if something's not quite right. I think there's a bearing problem on this pump over here, or anything like that. You study it, you feel it, you taste it, and you listen to it at all steps in the process.
So that is all there is to making beer.